Good morning, everyone, and welcome to another Aquarium Online Academy. My name is Tina. I will be stepping on the camera in just a moment. I'm just going to get my microphone all set up. But you have joined us for a very special program today. We are going to be talking all about crustaceans. Now, give me just one moment to put this microphone behind my ear. Alrighty. We should be good to go. Alrighty, now I'll go ahead and step on screen. We made it. We did it. Excellent. Thank you so much for joining us, everyone. As I said before, my name is Tina. I'm a part of the education team here at the Aquarium of the Pacific, but I am not alone in my studio. Today I have two of my friends. I have Connolly and I have Cole. They're going to be working the wonderful magic that you see behind me today. Now, during our program, if you are watching us live on August 19th at 10 o'clock Pacific Standard Time on 2025, you're watching us live. Please feel free to share with us your observations, share with us as we're teaching, as we are showing you all these fun things. You can do so by texting us in at 562-286-1838. We would love to hear your questions, your observations, your comments, anything like that. Please talk to us. We would love to hear from you. But if you're not watching us live on August 19th at 10 a.m. Pacific Standard Time, you're watching us at another point in time and space, please feel free to still interact with us and ask us those questions. You can do so by emailing us at live@lbaop.org. And one of my coworkers actually monitors that email, so we'll be able to get back to you. Alrighty, my friends, this number and the email are going to stay up during our program today, but I would love to kick us off by making some observations. Now, have we heard that term observation before? Give me a thumbs up if you know what an observation is, you've made one before, you feel confident in making observations. Nice. Connolly's giving me a big thumbs up. Thank you, Connolly. Thumbs in the middle if you have heard of it before, but you might need some more practice. And then Cole's maybe give me a little bit of a thumbs in the middle. And then thumbs down if you've never heard of what an observation is before, but you're excited to learn about it. Let me see where we're at. Okay, I got a pretty good mix. Well, my friends, we're going to talk about it anyway, so no worries. An observation is something we do with our eyeballs. We use our sense of sight, we look around our environment, and we take notes in our brains about what it is that we're seeing, what it is that we're feeling, hearing, maybe even smelling as well. I know from my studio here you might not be able to smell anything unless you're smelling things where you're at right now, but we absolutely can make observations about what we are seeing, okay? This behind me is one of the habitats we have here at the aquarium. This is our blue cavern habitat. This is actually a live feed of what's going on right this very moment in the aquarium. You can access any of our webcams on our website and check in on our animals whenever you would like. So, Blue Cavern is modeled after a real dive site off the coast of Catalina Island here in Southern California. And what I would love for you to do is, using your eyeballs, using that sense of sight, take a look at my habitat here. Tell me what you see, what you notice. Maybe even make some predictions, make some guesses. Maybe tell me if you think the water is warm, if you think it's cold, what you think the animals eat, anything like that, okay? We'll warm up those scientist brains, and then we'll jump into talking about our crustaceans. Does that sound good? Excellent, my friends. I'll go ahead and take a step off screen, and I want you to tell me what you see. We'll take about a minute or so to do that, and when you have those observations, please feel free to text us at 562-286-1838. You can text us in with what you're noticing, what questions you might got, or some of the predictions, okay? All right, I'll be back in just a couple seconds. All right, my friends, I am back. What did we see? What did we notice? Talk to me, people. What do we got? I can go ahead and kick us off. For one thing, I'm noticing the color pattern over here isn't very bright, isn't very vivid. I'm looking at a lot of, I'm going to say, earth tones. So I'm seeing a lot of grays, maybe even a little bit of a green or browns. What do we think? Do we agree with that? Give me a big thumbs up if you agree. Yeah, absolutely. So I'm also noticing that not only is the habitat or the environment that kind of a neutral color, what else is neutral color? Yeah, absolutely. The animals that are living here too. I'm seeing a bunch of different kinds of fish. I may have seen a ray pop around. Ah, speaking of which, perfect timing. Look at that. Perfect. That is one of our beautiful bat rays, and that has incredible color on it as well. We have a couple of different other animals in here, like some sharks. We have some other types of fish that are native to Southern California. One of the sharks are swimming right behind me. Hopefully they'll come out from behind the kelp. Up, right back there. Beautiful. But what we're doing today is focusing on some of the smaller animals, maybe some of the ones that we can't exactly see in this kelp forest. But before I move on to talk about that, are there any other observations that we would like to share on in with us? Maybe how the animals are moving around, how they're interacting with each other too. I'm seeing some are swimming kind of slow. I'm also noticing that there are a lot of groups of fish. Does anyone know what we call a group of fish? Very good. It is a school of fish, and I know a lot of us might be starting school this week. Maybe we're in school right now. Some of us might be starting later this week or next. And if you are, have an excellent semester, my friends, and hopefully your school gets the chance to visit us here. But if not, we would love to continue doing our virtual lessons for you and the rest of your classmates. All right, my friends, I think we got our scientist brain sufficiently warmed up. Let's go ahead and dive right into the topic of the day, which is crustaceans. Now, what is the first thing that comes to your mind when you hear of the word crustacean? What do you think? Maybe something like crusty? That's typically what I think of, crust. When we think of the word crust, that might be a little bit of an interesting feeling that you might get. Maybe we think of something that's tough or harder, right? Now, crustaceans are going to be animals that have a harder shell on their bodies, or what we call an exoskeleton. Can you go ahead and shout out, maybe write down, what kinds of animals do you think are considered crustaceans? I want to hear some examples of crustaceans. What do you know to be a crustacean? There's one that comes to my mind right off the top of my head, and I'm wondering if we're having the same thought pattern, if we're thinking about the same things. I think of crabs. Anyone else think of a crab? Does anyone think of something like this? This is a beautiful crab. Is this one of our spider crabs, Connolly? It just says crab. You know what? And it is indeed a crab, my friends. But take a look at this crab. We're looking at it from the underside. So this is the little belly of our crab. We're noticing their mouth, their eyes, but also all of these appendages. Can we try to count together how many appendages do we think this crab has? I see 1 here, 2, 3 down here. I think I'm only seeing 3 on this side. Correct me if I'm wrong, my friends. I'm also seeing 1, 2, 3 down here. Now you may notice that we can't actually see the legs in this picture because it's kind of cut off, but I'm counting something else that's not a leg. Do we notice when I'm counting? I'm focusing on this part of their body right over here. Who can take a guess as to what this part of their body might be? And do you have something similar on your body? Take a look. Ah, thanks for zooming in, Connolly. That's awesome. Take a look at your body. Do you have anything that might look like this or maybe move similar to this? If you said maybe your shoulders, your elbows, your knees, your wrists, I would absolutely agree with you because those are all different kinds of joints in your body. Crustaceans are a part of a really big family of animals called arthropods. We don't happen to have that word, do we, Connolly? I don't think we do. That's absolutely fine. I could spell it for you guys a little bit later if you would like. But an arthropod is an animal with jointed legs. But wait, we have joints, right? Everyone move your joints around. Move your legs, move your joints, get moving, get grooving. These animals are able to walk along the seafloor using their jointed appendages. And I'll tell you a little bit of a secret. They're actually related to some arachnids, like spiders and even maybe scorpions too, because they both have another thing in common that we don't have. Everyone make a muscle. Make a strong muscle. I've been going to the gym, so hopefully you see my efforts. In here, inside of your muscles, what do you have? You have bones inside of your body, right? But on top of your bones, what's all this stuff? All this squishy stuff? Your skin, your muscles, you have that on top of your bones. So your skeleton is inside of your body. But for arthropods, these animals, their skeleton is outside of their body. A lot of insects have this too. They have exoskeletons. That's what separates us from being an arthropod. Yes, we have jointed limbs, but no, we do not have a skeleton on the outside of our body. Our skeleton is inside. Do you know what kind of animal humans are, though? What do you think? We have bones in our bodies. I'm breathing some air. I have bangs that I have to cut. I have hair on my head, on my arms, my legs. I have warm blood in my body. And we don't lay eggs. So that, my friends, makes us mammals. So if you have dog, cats, or any other pets at home that isn't a fish or a reptile, they are also mammals too. But these wonderful crustaceans, there are about 67,000 different species of crustacean. Think about that for a second. That's a lot of different crustaceans. And they all do different things within our oceans or within our different kinds of water systems. Because there are some crustaceans that do in fact live in fresh water. The ones that we're going to be looking at today are going to be living in the ocean, so it's all going to be salt water. So we know crabs is one example of a crustacean. What do you think might be some other examples of crustaceans? Let's think of animals that are in the ocean that might have a hard shell and jointed legs. I'm thinking of something small. Think small, my friends. What do we think? If you said maybe a shrimp or krill, you would be absolutely correct, my friends. Now, I'm going to give Connolly just a moment to maybe pull up a picture of anything that they want. Oh, look at that. Perfect. A beautiful shrimp. What else are we noticing about this shrimp compared to their habitat? I'll go ahead and step off for just a moment. We got a question. What is a crab's lifespan? You know, that is an excellent question, my friends, and it could depend on the species, but I've been told that some crabs can live into their 30s, maybe even 40s, maybe even longer, depending on the species, right? So a very long lifestyle, I would say. Hermit crabs, it also depends too. They can live a little bit shorter, but if taken care of properly and if they're living in the ocean, they can even live to 15, 20 years too. So a pretty long time if they're well kept and they're nice and healthy. Excellent, excellent question, my friends. Keep those questions rolling on in, everybody. Feel free to text us in at 562-286-1838. Now, let's go back to our shrimp and take a look at something that we like to call adaptations. Have we heard of that word before? Adaptation. Let's use our gauge of thumbs again. Where are we at? Okay, we're a little bit everywhere. That's absolutely fine. That's a perfect place to be. An adaptation. I'm wondering, do we have that word maybe? Oh, we don't have that word either. My magical powers aren't working today, guys. I can't make the words appear on my screen, but that's okay. I can spell those for you later, too. An adaptation is something that an animal has on their body in order to help them survive in their habitat where they live. All right, that was a long explanation. But essentially, using humans as an example, what are these? Our hands, very good, maybe even our fingers too. Does every single animal have hands and fingers like us? No. Does a shrimp have hands and fingers? No, I think that'd be very interesting if they had little hands on their bodies to walk around, right? These hands help us to do a lot of things that maybe some other animals can't. Things like grabbing onto things or picking things up and helping us eat or helping us communicate with our friends too and our families. But this is something special to humans and other kinds of primates with our opposable thumbs. Other examples of humans, you can think of a bunch, but take a look at our shrimp over here. What do you think some adaptations for our shrimp might be? I'll give you a little hint to take a look at their color. I want you to compare their color to the color of the habitat they're standing in. I kind of touched on this a little bit when we were looking at our blue cavern habitat. What do you think? I'm definitely noticing some more muted colors, but I'm also noticing some patterns. I am noticing some polka dots. Some may even say they're stripes too. Definitely stripes over here. What we call this is camouflage. Can we all say camouflage? Very, very good, my friends. Camouflage is something that animals can do, or even sometimes humans when we wear different kinds of clothing, we can do to help blend in to our environment. These particular forms of camouflage, these spots, these stripes, we call disruptive camouflage. I know it's a big word, but it means that the camouflage isn't just one color. This has a pattern to it. This pattern is going to help this shrimp blend in to their environment. Now, if we could pull up maybe another picture of any kind of random crab too, it's not just color that can help our animals blend in, it's also what they might feel like if you were to use a gentle two-finger touch and touch the leg of the squat lobster. What do you think it would feel like? Would it feel soft and squishy like a marshmallow? Or would it feel kind of hard and bristly like a stick? What do you think? I would say stick, absolutely. Look at all of these little bumps on their bodies. This is absolutely useful for them to maybe help them blend into their environment that's a little bit more rocky, like that kelp forest that we saw earlier, too. Maybe it's this different kind of color because I'm noticing some other animals behind it that are also the same color, like this sea star that's over here. This looks like a sea pen, but I don't think it's a sea pen. I don't really know what that is back here. That's very interesting. Now, texture and color can help our animals blend in, especially our crustaceans blend in very, very well. Because there are a lot of predators that would enjoy crustaceans as a little snack. Different things like, octopus could eat a crab, otters, seals and sea lions, but also humans too, right? Has anyone ever eaten any kind of seafood or maybe even crab or lobster before? Absolutely. Seafood is very, very sustainable to, perfect picture, for us humans to eat, my friends. So we're always going to encourage you to eat that sustainable seafood. This is another wonderful picture of a couple of lobsters. What are we noticing about their faces? What's on their face that maybe our squat lobster or the crab that we saw before didn't necessarily have a lot of? Are we seeing these really, really long things in front of their face? I'm definitely seeing this. This one comes all the way out to here. Oh, no, even over here. That's insane. These are their antennae. What do you think their antenna might help them do? Do we know of any other maybe household animal that has little whiskers on their faces? Yeah, absolutely. Dogs and cats have whiskers. Our seals and sea lions could have little whiskers on their faces too. And their version of whiskers pretty much are their antennas. Their antennas are going to help them feel around their habitat. If you take a look at their eyes, do they have really, really big eyes or tiny, tiny eyes? Their eyes are kind of smaller, right? So that tells us that maybe they might need a little bit more help inspecting their environment. And these antennas can do just that. They can also help them find their food. These animals are going to eat things like smaller kinds of plankton, smaller kinds of algae, things that definitely live in the sand. Now, what's very interesting about their mouths, I'm wondering, I'm not too sure if we have a picture, Connolly, of like a close-up of a mouth, maybe? Yeah, Connie's going to try to find one for me real quick. But in the meantime, I want you to think of your teeth. Use your tongue, feel your teeth. What do your teeth feel like? Are they big? Are they small? Are they the same shape, same size? What do you think? Mine feel a little bit different. What do you think? Yours feel different too? Absolutely. Our teeth in the front of our bodies over here, in front of our mouths, they're a little bit more pointy. They're a little bit longer than our teeth in the back, and that's because it helps us bite down our food. Now our teeth, oh, perfect. Thank you, Connolly. Our teeth in the back are a lot flatter and maybe just a little bit smoother, right? And these back teeth help us to chew our food. Our teeth do different kinds of things. Crabs and crustaceans, they don't have teeth like us. Instead, they have bristles, almost like a toothbrush, right over here. I know it's a little bit blurry. It'll clear up in a second. These bristles, like a toothbrush, they kind of use to tear up their food very, very tiny and very, very slow. And they'll almost dissolve their food, almost. Not like our stomach acid dissolves any kinds of food, but they'll break it up into tiny, tiny little bits. Some of our larger crabs or even horseshoe crabs can eat things like smaller pieces of fish as well, and they're really good at using those bristle-like teeth to help them eat their food. Now, what I would love to do next is jump over to my document camera to show you a couple of molts from some crustaceans. Let's pop on over, my friends. Let's take a look at what I got. Alrighty. Oh, I have it zoomed in. Sorry about that, my friends. There we go. Alrighty. We got a plethora of molts. This is also me. Hi, everybody. When I say molts, you might be seeing it looks like I have a full lobster right over here and a tail. But do you think that there's an animal in here? No, there is not. If this was a live animal, I would want it to be in the water so it could live, so it could breathe, right? But this is what we call a molt. Remember how I said they have exoskeletons? Their skeletons are on the outside of their body. What happens to our skeletons when we go from babies to adults? Do our skeletons stay the same size? Or do they change size? Absolutely, my friends, they change size. And when we grow, we need to buy new shoes, new clothes, different things to help fit our bodies. These animals grow too, but in a little bit of a different way. Their skeletons or their exoskeletons aren't going to grow with them as they age. They're going to stay the same size until that animal decides to shed its exoskeleton. What these animals will do, so if this was our whole lobster here, what they will do once they're ready to molt is start to peel out of this exterior shell, and then they're left with a soft, squishy body. Well, they'll wait till their new skeleton forms. So this is from a skeleton. This is from a lobster that has molted. Let's take a closer look at their anatomy a little bit. I want to point out this tail right over here. Now, a lot of us might seem that this is a very delicious dinner, and you know what? I would agree. Lobster is very sustainable to eat. It is very, very good as well. But I want you to take a look at these little fins right over here and these little sharp edges here too. Typically, we would have some more little legs or more little fins here as well. We call these the swimmerettes, or very similar to swimmerettes. These will help our lobsters swim around. I'll tell you something a little bit weird. Some lobsters, they swim upside down. I know. Very, very weird. I can't bend this because it will break, but they will kind of curl their tail upwards like this to help push them through the water while they're upside down. This is also how some horseshoe crabs will swim, using those powerful swimmerettes, using their tails and all of these joints in their bodies. And then let's take a look at this one. Let's take a look at these little pinchers over here. I don't know if I have the full set here, but we also know that a lot of our crabs will have really powerful claws to do what? What do we think? Absolutely, to crush through that food. And this is where those antennas would be, right? So the longer part of that antenna kind of came off with that softer body of our other crustacean friends. Take a look at that texture too. Very, very rough, very, very bumpy. I would say it's very similar to a rock, 100%. Look at all of these legs. Do we see those little joints that we were talking about before, that we counted before? I would agree. Now I also have a little plate of some krill. Let me see if I can get it a little bit closer to you guys. Do we see those little black dots? Those are the eyes of our krill. Now, not only is our krill a kind of an arthropod, an exoskeleton animal with jointed legs, it's also a kind of a plankton. Now, plankton is an animal that can't swim against the current of the ocean. That means that they don't really have much choice about where they go in the ocean. They pretty much go with the flow, man. They are very, very cool, just like some of our jellies and other kinds of plankton, too. I'm going to show you this one. Or no, I'm going to show you this one, actually, because this is one of my favorite ones. This is a molt from a horseshoe crab. Now, we don't have these here in Southern California, but I am actually from, oh, can I open this up and show you? Yes, I can. I am actually from New Jersey. I am from the East Coast, and we would have these little critters everywhere on our beaches. Our horseshoe crabs are so cool. How do we think they got their name? Yep. It's because they kind of look like a little bit of a horseshoe. This right over here, sometimes people think that these look like stingrays, which is incredibly fair because they have what looks like a tail here or a barb even. But this is a wonderful adaptation that helps our horseshoe crabs flip around if they're ever on their backs for too long. Take a look at that. So here's where they would have their gills. We call book gills because they fold almost like pages of a book. This is where their mouth would be, right in the middle of their little legs. Let me focus. There we go. We can maybe even see those little bristles. Let me focus again. Wait for it. There we go. See those tiny little bristles in there? That's where their mouth is. We see some of their book gills. And this is a little tendon that's very, very sensitive. When our horseshoe crabs are on their backs like this, they will use their tail to dig it into the sand. Let me zoom out a little bit. Once they dig it into the sand, they'll use it to help them go floop, to flip back over. And all of these spines are, of course, just like our other crustaceans, used to help protect themselves. Isn't that quite wonderful? That is, again, another molt. So this was a baby hermit crab that was getting ready to be even bigger. Alrighty, my friends, we got a couple more minutes left, and I know I promised you some spelling for some words, right? So let me go ahead and grab a whiteboard. I'm going to move these guys off to the side. Thank you. Thank you all for your hard work. Thank you. Thank you. Okay, so the words that we wanted to spell together were adaptation, and what was the other word? I don't remember. Arthropod and adaptation. So, adaptation. So we can take the word adapt out of adaptation because that tells us that our animals are adapting or they're making changes to fit inside of their environment, right? And then our last one was arthropod. Pod. Now, I made some space in between here just so that I can circle the word pod and underline arthro. So, pod, move this up a little bit, is actually a root word for foot. Arthro, have you ever been to, I'm trying to think. Maybe we've heard of something called arthritis before. That means that you have pain in your joints, right? So this can help us say joints. So jointed feet or jointed appendages, jointed legs, essentially is what our arthropod means. So here's the spelling for these two words as promised. Alrighty, my friends, it is time for me to wrap up. I'm going to go ahead and step back on screen. I want to thank you all so much for joining me in this lesson today. I hope you learned a little bit more about arthropods, a little bit of a better appreciation for them, and all of those cool adaptations that they have on their body to help them survive in their environment. We took a look at some crabs. We counted some legs. We talked about those antennas, that coloration, that texture, those teeth that they have, even those pinchers that they use to help them grab their food too. We talked a little bit about what they eat as well. And these are all some of the ones that you can find right here in Southern California, with the exception of the horseshoe crab. So if you're ever on the East Coast and you see a horseshoe crab, give it a little wave, tell it that Tina said hi. Alrighty, my friends, thank you so much for joining us on this wonderful Aquarium Online Academy. We look forward to seeing you on Thursday for our next couple rounds of Aquarium Online Academy. Until then, have an excellent day, continue to care about our oceans and about each other, and have a wonderful rest of your summer, everyone. Bye, thank you for joining.